Okay, hello grade 8. Once again, we will complete our geometry curriculum. The third lesson in the last unit is converse of Pythagoras theorem. Okay, we took before Pythagoras theorem and we revised it a lot in the class, but let's revise it once more here. Pythagoras theorem means if I have right angle, and it deal with right angle triangle only. If I have a right angled triangle, the Pythagoras theorem said that the area of the longest side, which is the hypotenuse, this is called the hypotenuse, the side which is opposite to 90 degree. The area of the square, which I draw it on the side of the hypotenuse, equal, sorry, this one is so big. The area of this one equal to the sum of the two areas drawn on the other two sides, the squares drawn on the other two sides. For example, if this side is 4 and this side is 3 and this side is 5, if you want to get the area of this one, 5 square, the area of a square, side square, to equal 25. Okay, this is the area. The area of this square, 4 square equals 16. This is the area of this square. And the area here is 9. When you add the area of the two squares here, 16 plus 9 equal 25, which is equal to the square drawn on the hypotenuse. Okay, but we already applied Pythagoras theorem on any exercise. If I have a triangle and he told me that this triangle is 90 degree, ABC, and for example, if this one is 6 and this one is 8, find AC. We didn't draw any squares and we didn't do any of this. This is only the meaning of Pythagoras theorem. And by another way, I said that the longest side is square, this side square, that's why I'm putting a square, AC square. If missing the hypotenuse like this one, it is equal to the other two sides square, the sum of the other two sides square, AB square plus BC square. Okay, so AC square will be AB square, which is 6 square, BC 8 square, 6 square 36, 8 square 64, so it is equal 100. This is AC square. If you want to remove the square, so AC will be equal root 100, which is equal only positive. We will not add here positive or negative because there is no side with negative. Okay, what about if I have a right angle triangle and he told me that this is 5 centimeter and one of the two sides missing, this is 4, and I want the length of AB. AB here is one of the sides. It is not the longest side, it's not the hypotenuse. Okay, so if I want one of the two sides, I will subtract the longest side square minus the other side square. So AB square will be equal AC square minus, in this case, BC square, because there is no sides greater than the hypotenuse. So it will be 5 square minus 4 square equals 25 minus 16 equals 9. So AB equals root 9 equals 3 centimeter. This was revising Pythagoras theorem, and also we can go to the video uploaded by Mr. Muhammad Al-Moor or Mr. Muhammad Al-Alaidi, the teachers of grade 7. You will find this lesson as a video if you want more practicing about this one. Okay? What is the converse of Pythagoras theorem? Converse of Pythagoras theorem means the opposite. The opposite means that he will not give you that this is a right angle triangle. He will give you only the three sides. He will give you the three sides of the triangle, and he wants you to prove that there is a right angle. Okay? So the converse says that in a triangle, if the sum of the areas, if I have a triangle, here a triangle, and the sum of the areas drawn on two sides, any two sides of the triangle, if the areas of the two squares drawn on two sides of the triangle equals the area of the one which is drawn on the third side, so this angle is right. Okay, so in a triangle, if the sum of the areas of two squares on two sides is equal to the area of the square on the third side, then the angle opposite to this side is a right angle triangle. By another meaning, I can write it written as, in a triangle, if the square of the length, okay, that's why we are putting square, AC square, BC square, and so on. If the length of a side square is equal to the sum of the squares of the lengths of the other two sides, then the opposite angle opposite to this side is right. Okay? Okay, let's take an exercise. If I have a triangle, and for example, I have this side is 13 centimeter, and this side is 12, and this side is 5. ABC, and I want to prove that measure of angle A equal 90. I want to prove that measure of angle A equal 90. To prove that measure of angle A equal 90 means I want to prove that the triangle is a right angled triangle, right? How to prove it? To prove that there is an angle which is 90 degree in the triangle, I must have the three sides. The three sides here must be given. Okay? I will take the longest side square. I will tell him that since BC square, the longest one is square only, alone, equal 13 square. 13 square is 169. This is number one. Then the sum of the other two sides is square. AB square plus AC square equals AB square, 5 square plus 12 square equals 25 plus 144 equals 169. So as you see that the sum of two sides of a triangle, the square of two sides of triangle, equal the side square of the third one. Then which angle is 90? The angle opposite to the longest side. So BC, the opposite angle is A, so measure of angle A equal 90. From 1 and 2, since BC square equal the sum of the other two sides square as proved, AC square, so therefore measure of angle A equal 90 degree. Is it easy? This is all the lesson. This is the lesson. That's all. Okay? Let's see some practice. And there is a corollary in a triangle. For example, ABC. If AC is the longest side and AB square plus BC square doesn't equal to AC square, so the triangle is not a right angled triangle. To be a right angled triangle, the longest side must be the square of the longest side must be equal the sum of the other two sides square. Okay? Here exercise 6.2 in your book. Complete and show which of the following triangles is a right angle triangle and which is not. Okay? Let's see. Number A. This is the F, not the E, by the way. This is a mistake. I have the three sides as you see. To determine whether it is a right angle or not, I must have the three sides. DF square, which is the longest one, 7. So 7 square equals 49. DE square plus EF square, the other two sides square, 25 plus 6 square, 36, gives you 1 and 61. So this is 49 centimeter, this 61 centimeter. Are they equal? No. So is the triangle right? No. So the triangle is not right angled triangle. What about this one? Where is the longest side even if it is not complete? I'm looking at the longest side. The longest side here is MN. So this will be in a step alone. So MN square equals 13 square, which is 169 centimeter. ML square plus NL square, the other two sides. If the square of the other two sides equal 169, so the triangle is right. ML square equal 144, which is 12 square. 5 square, 25. When adding, it will give you 169 centimeter. So the sum of the other two sides square equal the longest side square. So the triangle is right angle triangle. Okay? You will find another two practicing complete, but I will not do it now. Maybe I will do it in the online session, inshallah. These are the two. Okay. What about to take one of the exercises here? Prove in the opposite figure. I have here, as you see, I have two triangles. Okay. Let's see what I want. AB 3 centimeter, BC 4 centimeter, AD 13, DC 12. Measure of angle B equal 90 degree. This is given that this is 90. So triangle ABC is already a right angled triangle. Okay. Prove that measure of angle ACD is 90 degree. I want to prove that this angle is 90 degree. Okay. To prove that there is an angle of 90, I must have the three sides. Right? Do I have the three sides? No. I have only AD and I have DC. So I must get what? I must get the length of AC. In order to prove that there is an angle of this triangle 90, I must have the three. So AC is missing. What you will do? Look at the triangle ABC. I will take it outside. This is a right angle triangle. ABC. And this is right. This is 3 centimeter and this is 4. If you have a right angled triangle and you have two sides of it, can you get the length of the third side? Yes, of course, by Pythagoras theorem. Okay, so in mainly 90% of the exercises of this lesson depends on both Pythagoras theorem and the converse of it. Okay, as you see here, all the exercises, even this one, it is two triangles. Each one is two triangles, one by applying Pythagoras and the other by applying the converse of Pythagoras. So first I'm talking about in triangle ABC. Since measure of angle, this is a normal Pythagoras theorem, measure of angle B equal 90 degree, AB equal 3 centimeters, BC equals 4 centimeter. Therefore, AC square equal what? This is what? This is the hypotenuse, the longest side. So I will add the sum of the square of the other two sides. So it will be AB square plus BC square. AB square 3 square, BC square 4 square, 9 plus 16 equals 25. Therefore, AC only equals root 25 equals 5. So half of the question is Pythagoras theorem. Two sides, right angle, I will apply Pythagoras. So I got AC 5. Now if I took the triangle, the other triangle outside and I draw it here, for example, the triangle here, he wants me to prove that this was A, C, D. He wants me to prove that measure angle C as 90 degree. I already have now AC, I got it 5 centimeter, and given DC 12 with AD 13, this is 12 and this is 13. Now I have the three sides. Can I prove that this angle is right? I want to prove that this angle is right. Yes, by doing what? Taking the longest side alone. By chance that the numbers are repeated. Okay, but it's not a must that each time will be 13, 12 and 5. Okay, so AD sense AD square. This is why I have started with AD, because this is the longest side in our triangle. So AD square equal 13 square equal 169. This is number 1. Then the sum of the other two sides is square, AC square plus DC square, which is equal 12 square, sorry, this is 5 square plus 12 square equals 25 plus 144, which is equal 169. So this is number 2. From 1 and 2, from 1 and 2 what? AD square. It is equal, exactly equal to the sum of the other two sides square. So therefore measure of angle ACD equals 90. So as a summary, I have Pythagoras. If I want to prove by Pythagoras, I must have a right angle and two sides of the triangle to get the third side. Then using the third side, or if I want to prove that there is an angle of measure 90, I must have the three sides of the triangle, taking the longest one square alone, then the sum of the other two sides square alone. If they are equal, so the triangle or the angle which is opposite to the longest side is a right angle. That's it. That is the lesson of that is our lesson today, converse of Pythagoras theorem. Also, I will solve more exercises inshallah in our online session. Thank you, grade 8.